In this question, we have two population and two samples obtained from population, and the problem is as follows. Two quality control technicians measured the surface finish of a metal part, obtaining the data in the table given here. So the data table is given here, and we have it on Minitab too. We upload that to Minitab down here. The question is, test the hypothesis that the mean surface finish measurements made by the two technicians are equal, which is mean 1 equals to mean 2. Alpha, we choose alpha to be 0.05 and we assume equal variances. So our test hypothesis is going to look like mu1 minus mu2 is equal to 0 versus h1, which is the alternative hypothesis, is mu1 minus mu2 is not 0. And we remind that we reject h0 if the absolute value of t naught, the test statistic t naught, is strictly greater than t alpha over 2, comma, n1 plus n2 minus 2. Right now, okay. So we have to calculate this SP, and SP, the formulation was given before, I gave you in class, and 0.1204, and T naught is calculated as follows: x1 bar minus x2 bar minus 0 over SP square root of 1 over n1 plus 1 over n2, and then we get that it is equal to the T naught value is equal to 0.11. This is all by hand. And then we also we want to compare this with T alpha over 2, n1 plus n2 minus 2. So we go to T table and we get that value too. The value is 2.160. So we compare these two values. So we do not reject H0 because T0, absolute value of T0 is less than T alpha over 2. So that, in other words, there is not enough evidence of a difference between measurements obtained by two technicians. Now we are going to do this on Minitab. On Minitab we do this as follows. We go to stat, we go to basic statistics, and then we choose to sample T. Okay. There are options like both samples are in one column. That's not the case in our case. Each sample is its own column. That's the case for us. And then 17, so we select for sample 1 this. For sample 2 we select this. Okay, and then we check the options. This is alpha is 0.05, so this is confidence level is going to be 95%. This is the difference, sample 1 mean minus sample 2 mean. Hypothesized difference is 0, and alternative hypothesis test is not equal to. And we have to assume that variances are equal. That's what we started with. And then graphs, we don't need that, so I'm going to just click on that. So when we click on that, this is the two sample t-test, this data and this data. Okay, mu1, mu2, they are the means, and the difference is mu1 minus mu2, and equal variances are assumed for this analysis. It says it's here. And then we look at the descriptive statistics, standard deviations for each sample, and mean is given, and the difference, pooled standard deviation is given, difference is given, 95% confidence interval is given up here, and also the test hypothesis is here. T value is 0.11 as we found here, and then degrees of freedom is 13, and p value is 0.9117, and alpha is 0.05. P value is bigger than 0.05, so we fail to reject H0 because there aren't enough information or evidence to do that. Okay, and in part B, so we got that. In part C, actually, it says construct, assuming the variance are equal, construct a 95% interval, which is already done here, the 95% confidence interval. In part D, test the hypothesis that the variance of measurements made by the two technicians are equal. So our test is going to be as follows. Test sigma 1 squared is equal to sigma 2 squared versus sigma 1 squared is not equal to sigma 2 squared. Okay, so we have this F table coming into play. If not, test statistic is the ratio of S1 squared over S2 squared. Okay. Okay. Then what do we do? For this, we have to go to stat, basic statistics, because comparing variances. So let's see whether we have the variances. We have two variances here. We choose that. Both samples are in separate columns. Okay, so we are going to choose that. And then sample 1 is the same and select that. Sample 2 is the second sample and we select that. And the options, we are going to choose sample 1 standard deviation over sample 2 standard deviation. Okay, the ratio test. Let's check what else do we have. Sample variance over sample 2 variance. Okay. Okay, so okay, so we confidence interval is 9 to let's see what was I think again 005. Let's see, alpha, what's alpha? I think 005 again. Alpha over 2, yeah, 005. 95% hypothesis ratio is 1. Okay, because equality. And alternative hypothesis is not equal to. Okay. Okay, let's click OK. And we click OK. Okay, so we get this information. Let's see, f-test, p-value. Let me see whether we have the same output here. See, we get the f-test p-value 0.852, and confidence interval it should be, let's see, it should show it somewhere. Okay, I should be able to see that somewhere. Okay, so we can see the separate confidence intervals for each year. Okay, confidence interval for variance ratio, it's in here. Okay, and box plotted here as well. Okay, so we do not reject H0 because p-value is big. Okay, and that's what we get from here. Part E is similar, so we are not going to do that. That's the end of the question.